Okay guys, let's get started. Introduction to algebra. I believe you must have come across mathematical problems that involves looking for x or y or z or a or b or c, anything that involves alphabet. Now, anytime you come across problems like that, you have actually come across the concepts referred to as what? Algebra. Because algebra in mathematics uses letters to represent what? Numbers. Now, this concept of algebra is really a large concept. We're not going to finish all that, but we are going to start off with the basics of algebra. Now, what are the things we are going to cover in algebra? Now, we're going to start with the simple problems, especially the key things that are involved in algebra. This key foundation knowledge will help you to climb the ladder in algebraic problems. So let's get started with some examples. Now, the first thing you need to understand is in algebra, when you have a single term, probably a or x or y or 2 or 3, these single terms are referred to as mononomials. They are called mononomials in algebra. And mononomials is simply single terms. When you have two terms, probably a constant and a variable. Let's say you have bounded by addition or subtraction. Let's say I have something like this: 2x plus a, or 3x plus y. This is called binomial. Binomial. What do we mean by binomial? Meaning it consists of two terms, the first term and the second term. If you have something like this: 3x squared plus 2x plus 4, we call these trinomials. It can come in this form: 3y squared plus 2ab plus ab squared. As far as it comprises of three terms, 1, 2, and 3, we call it what? Trinomials. The ones involving more than three terms are referred to as polynomials. Okay, so that is it. That's the first foundation knowledge you need to remember when you're dealing with algebra. Understanding that when you're dealing with a single term, we call it a mononomial. When you're dealing with a double term, binomial. Three terms is trinomial. When you're dealing with terms more than three, you call it what? Polynomials. Now that's been done. And the next example we're going to look into is what we call collection of like terms. Now, what do we mean by like terms? In mathematics, when you see 3ab, it simply means 3 multiplied by a multiplied by b. If you have 4x, 4x simply means 4 multiplied by what? X. So when you talk about the concept of like terms, what we are interested in is if I have 2x and 3x, because there is x here and there is x here, these numbers are called like terms. If I have 5y, 6y, 7y, because there is y here, there is y here, there is y here, they are called like terms. And in algebra, when you have like terms, you can perform some arithmetic operation on them, such as addition and subtraction. You can add like terms and you can subtract like terms. But when you have concepts that involves x and y, let's say we have this problem. Let's say you have something like this. Let's say you have 2x plus 3y plus 4x. And you are asked to solve these problems. Now, the first thing you need to understand is that you can notice that we have like terms here. We have these 2x here and we have 4x here, which are like terms because they have the same variable, x. So we can bring them together and add them up. So to add them up, we simply add 2 plus 4. And what is that? We have 6x plus what? 3y. We cannot add these 6x and 3y because two of them are unlike terms. So that is one knowledge you need to understand when you're dealing with what? Algebra. You can only add like terms, but you cannot add unlike terms or subtract unlike terms together. All right. So feel free to pause the video and tell me what this one could be. If I have 2x plus 3y plus 5x plus 6y. Simplify and tell me what the answer could be. All right, so let's get started. Notice that we have a like term here and a like term here, 2x and 5x. They are like terms because they contain the same variable of x. Notice that we also have a like term here, 3y and 6y. They are like terms. So what we do is we collect them together. So let's collect the like terms. We have 2x plus 5x. Let's collect the other like terms. We have 3y plus 6y. And what do? We can add the like terms together. 2 plus 7, we have 7x. 3 plus 6, we have 9y. And this is the answer. Okay, now solve this. The same thing applies to subtraction operation. So let's say we have 2x squared plus 3x plus 3y plus 5x squared plus 7y. Feel free to pause the video and try this problem yourself. So notice again that we have a like term here, x squared, 2x squared, and 5x squared. So because these and these are like terms, we collect them together. And when we do that, we have 2x squared plus 5x squared. Then because we have 3y here and 7y here, they are like terms, we collect them again together. We have 3y plus 7y. And when we solve this guy together, we see 2 plus 5, and you have what? 7x squared plus 3 plus 7, we have what? 10y. And that is the answer. So let me give you one more problem before we move to another concept. So try this problem for me. We have 3a plus 5b squared plus 7y plus 8b squared plus 2a plus 3y. Can you solve that? Feel free to pause the video and try that problem out yourself. Now, the best thing you're going to look at yourself is what are the like terms first? What are the like terms? You can see that we have 3a here and we have 2a there. So we can collect these two like terms together. So we have 3a plus 2a. Which other like terms can we see? We have 5b squared and 8b squared. See the like terms here? b squared, b squared. So we collect them together. We have 5b squared plus 8b squared. And what other like term do we have? We have 7y and 3y. We collect them together as 7y plus 3y. And so we evaluate 3a plus 2a, we have 5a. 5b squared plus 8b squared, we have 5 plus 8, we have what? We have it to be 13b squared plus 7 plus 3, we have 10y. And that is the answer. Now, this is the concept of collection of what? Like terms. This concept is very important in algebra. Notice that we cannot add unlike terms, but we can add like terms together. The same thing applies to subtraction operation. When you subtract variables together, let's say you have 2x squared minus 3y plus 3x squared plus minus 2y. To solve this problem, notice that this is a like term, 2x squared and 3x squared. They are like terms. So we collect them together. We have 2x squared plus 3x squared Then these like terms again, minus 3y and minus 2y, we collect them as minus 3y minus 2y. Now when you have this and this added together, we have 2 plus 3, we have 5x squared. Now when you have minus 3y minus 2y added together, it will give you minus 5y. Now, let me break this concept a little bit down. Whenever you have a problem involving minus a variable minus a minus b, how to tackle this problem is you need to understand that minus multiplied by minus will give you what? Plus. Minus multiplied by plus will give you minus. Plus multiplied by minus will give you minus, and plus multiplied by plus will give you what? Plus. This is the basic foundation to understanding how to solve problems on that. And then whenever you are adding two variables together, let's say I want to find minus 2 minus 3. To solve this problem, what you do is you simply multiply the signs. Minus times minus, you have what? Plus. It means that the operation is add the two numbers. And when I add these two numbers, 2 plus 3, I will have what? 5. And this 5 will take the sign of the bigger number. Between 3 and 2, which is the bigger number? 3. And the sign behind it is what? Negative. And that means that minus 2 minus 3 will give you what? Minus 5. Now let's try out another problem. When you have minus 5 minus 8, or minus 5 plus 8. How do you solve this problem? Remember, the whole thing is there. You just simply take this sign, multiply by this. You have minus times plus. Minus times plus is what? Minus. So you subtract the two numbers. Subtract the smaller number from the bigger number. You say 8 minus 5. What will it give you? 8 minus 5 is probably what? 3. Now this 3 will take the sign of the bigger number. The bigger number here is 8 and it's positive. So minus 5 plus 8 is plus 3. Now, what if we have plus 5 minus 8? How do we solve that problem? The same way, we simply ask ourselves, minus times plus will give us what? Minus. It means the operation we are going to carry out is subtraction. So we simply subtract 5 from 8 and we have what? We have 3. Now this 3 now take the sign of the bigger number, which is what? Minus. So the answer becomes minus plus 5 minus 8 is what? Minus 3. Now you can see that this is the way to solve problems involving negatives. So whenever you have negative problems, you simply remember this table and then use it to solve that particular problem. All right, let's move over to the next concept. Okay guys, another important knowledge that we need when dealing with algebra is the knowledge that we are going to encounter whenever we are tackling with problems involving equations. And this knowledge is connected directly to the real meaning of algebra, which is finding the unknown variable. Now, whenever you are dealing with algebraic problems, you come across x, y, z, whatever. Now, it is not just enough to simplify the problem, just like when we have 3x plus 2y minus 10x plus 8y. When you have this kind of problem, to solve them, what do? You collect like terms, which is 3x and 10x are like terms. You bring them together. 3x minus 10x plus 8y plus 2y. Now what do? You subtract 3 minus 10 will give you minus 7x plus 8 plus 2 will give you what? 10y. And this is the answer. Now, this is simply a mere simplification. Now, in the real problem of algebra, this particular problem now will be equated to a certain number. And then the question will be, find the value of x and y. And that is when we'll be dealing with, that is what we refer to as algebraic equation or algebraic processes. Now, to tackle problems like that, there are some important knowledge that we need in order to solve such a problem. And that is what I'll walk you through in this particular section. And what is that? Now, let's start off with this example. if you get a variable, a number, let's say 2, and a variable x, and these two numbers are bounded together by addition, and they are equated to a certain number, let's say 5, and you're asked to find the value of x. To solve this problem, what you do is you need to make x to stand alone. And to make x stand alone, always remember that this equality sign here is serving as a bridge, demarcating two sections, which are section 2 plus x and section 5. Now this is a different section, why this is a different section. But the question is find x. As a matter of fact, make only x to stand on this section. And the only way to make x to stand on this section is to eliminate these two that is here. And to eliminate these two that is here, what we do is we find out the operation that is holding these two together with x. And what operation is that? It is what? Addition. These two is addition that is holding it. Because any number that is standing alone is bounded by a positive sign. As a matter of fact, this 5 that is standing here is bounded by what? A positive sign. So to remove these two, we do what? We subtract. We just take the opposite operation that these two is having and add it to both sides, and x will stand alone. So what do we do? Since these two here is bounded by a factor of addition, we are going to use what? Minus 2 to remove him. So in that case, we will now say that we will subtract 2 from both sides. So we say minus 2 here, minus 2 here, then we solve. So to solve that, then what do we have? 2 minus 2 will give you what? 0. Then we now have our x standing down. X plus, this plus is something as writing x. And our equality sign is still there. Then 5 minus 2 is what? 3. And that will give, that is the answer. Okay, so let's try out another problem. So if you have 10 plus, okay, if you have x plus 2 equal to 15, how do you solve this problem? Remember, find the value of x. To find x, what do we do? We can see that the equality sign is demarcating x plus 2 from 15. So what we do is that we need to make x to stand alone. To make x to stand alone, we need to remove what? 2. And to remove 2, we need to find the operation that is bounding this x with this 2, and that is what? Addition. 2 here is added, is addition operation that is bounding it. So we take the reverse, which is subtraction. So we subtract 2 from this side, subtract 2 from this side. Then we calculate. And to do what? What is this? X is, we just bring down x. 2 minus 2 is 0. We just leave it is 0. Then we bring down our equality sign. 15 minus 2 is what? Is 12, is 13. And x is probably equal to what? 13. And that is the answer. So you can see that whenever an operation, whenever a given equation involves involve a variable and a number bounded together by a factor of addition, in order to make x to stand alone, we need to what? Subtract or add both sides by the inverse of that operation, which is bounding it what? Together. The same thing is applied when you have problem like this. When you have, let's say this thing is bounded by subtraction. Let's say minus 12 is equal to 15. How can you solve this problem? Because it is minus 12, what do? You add. So this is going to be what? Plus 12 plus 12. So let's bring down x. Minus 12 plus 12 will give you what? 0. So you don't need to write that down. So just bring down equality. 15 plus 12 is what? 15 plus 12. So let's add. 5 plus 2 is 7. 1 plus 1 is what? 2. So x is equal to what? 27. And that is the answer. Pretty simple. Now let's try out problems. Now this is when these variables are bounded together by what? Addition and what? Subtraction. Like I've told you, we are still on linear algebraic equations. So when these variables are bounded by addition, you use what? Subtraction. When it is bounded by subtraction, you use what? Addition. So that is how we tackle that kind of problem. Now, what if they are bounded together by multiplication? What do you do? Now, look at this variable. If you have a number 3 bounded by a variable y by a factor of what? Multiplication, being equal to, let's say, another variable, let's say 9. How do you solve this problem? Remember what I told you? When you have 3 multiplied by y, it's something as writing 3y equal to 9. So when you have something like this, we're no longer going to use addition or subtraction operation as the case may be. Now we are going to use the opposite of multiplication, which is what? Division. So since this variable is bounded together by multiplication, to eliminate one of the variables, we do what? We divide. So because we are looking for y, we are going to divide by what? 3. So we divide here by 3, we divide here by what? 3. So when we divide, this 3 can take care of 3, you have y down. So 9 into 3, you have what? 3. And that is the answer. So let's take another example. So if you have 2x equal to 10, find x. Feel free to pause the video and tell me what the value of x is. So to find x, what do? You divide by 2, divide by 2, because the two of them are bounded by multiplication, so you divide. So with this into this, you have what? X. So 10 divided by 2 is what? 5. And that is the answer. Now, in general, what are we trying to emphasize here? When you have two variables bounded together by addition, you use what? Subtraction to eliminate one of the variables. If they are bounded together by subtraction, you use what? Addition to eliminate one of the variables. If it is bounded together by multiplication, you use what? Division to eliminate one of the variables. Now, so let's look at the case when it is bounded together by a factor of division. What do we use? We use multiplication. Now, let's take an example of that kind of problem. Now, let's say we have something like this. Let's say we have x over 3 equal to 5. So how do you tackle a problem like this? Now, always remember that whenever you have a problem, whenever fraction is involved, that the other side of the problem is also going to be put in form of a fraction, but it's going to be over what? 1. As a matter of fact, anytime you have a number, every variable, let's say 1, 2, is simply 1 over 1, 2 is 2 over 1, 5 is 5 over 1, 8 is 8 over 1. Any number standing alone, whenever there is fraction involved, is that number over what? 1. So that being noted, the next thing you need to find out is to do what? Since this x over 3 is bounded by what? The factor of division. So what do? You simply what? Multiply both sides by the variable. So what I will do is what? Since I have x divided by 3 here, x and 3 are bounded by division. So I will multiply both sides. I will say x over 3 times 3 is equal to 5 over 1 times what? 3. And when I do that, I'll have that 3 can cancel 3. You have x standing alone. 5 times 3 will give you what? 15 over 1, which is something as 15. And that is the what? Answer. So in division, what do you use? You use multiplication. So let's take out another problem. Let's say you have y over 5 is equal to 2. So feel free to pause the video and try this problem yourself. Remember, this 2 is over what? 1. So because this y over 5 is here, so what do? This 2 is bounded together by 5. So to eliminate this 5, we multiply both sides by the what? By the coefficient of this guy. So what do? We just multiply by 5. So we have y over 5 times what? 5 is equal to 2 over 1 times what? 5. So when we multiply 5, take care of 5, y will become equal to 2 times 5 is what? 10 over 1. And 10 over 1 is something as what? 10. And that is the final answer. So this is one knowledge that you need to understand when you are dealing with problems in what? Algebra. So we have completed in this video concept, we have completed some of the foundation knowledge that we need when tackling algebraic problems.